is the first part of the Lab A1, and this is lighting the Bunsen burner. So this is a lab burner, a Bunsen burner. It's connected via some pretty stout tubing to a gas jet, and this style of burner has a gas valve back here called a needle valve, and this valve allows gas to flow into the burner itself. If this is all the way closed, you're never going to light it. And so this needs to be open at least a little bit. Here, above that, at the bottom of the barrel, are ports that adjust basically the fuel-air mixture, just like a carburetor in an engine does that. And if they're all the way closed, you're not getting very much air in. You've got almost entirely natural gas. If they're all the way open, you're getting lots of air in your mixture. You can also see down in the bottom, if you look into that air port, the actual gas flow itself, you never want to see fire there. If you look and see that there is fire burning in there, you need to shut the gas off immediately. That's bad. So, to light this, I generally put the ports at about half open. I'm going to set that down. This is a striker. If you scrape that across there, you generate sparks. Anybody who's welded has used one of these to light a welding torch. I remember one year watching somebody who had never lit anything, I think, in their life, take this, turn the gas on, and go. No. You have to hold it above the gas and create sparks, and those sparks are what are going to light the stream of gas. So, to light, I typically, and my hair is back, I typically turn the gas about full on and spark. Now, that flame is way too high. That flame is hitting about here. So now I'm going to back my gas down to about half, and then any further adjustments I can make with the needle valve. So I can, oops, I just closed it off entirely. So when you do that, just close the gas off. So I'll relight. There we go. And then again, back the gas down to about half. So I've got a nice little blue flame. Now, if I close, extinguish the flame altogether. A little bit more gas there. There we go. I'm going to get this down to about the right size. If I close these ports all the way, and this one is a little bit bent up, so it's actually, you really can't close the ports all the way. If I close the ports all the way and I'm not getting a good fuel-air mixture, I'm going to start to see yellow and orange in my flame. That's called a luminous flame. And oh, there we go. There was a beautiful luminous flame. It's horrible. I don't ever want to see that. Yeah, it's really tough to even get one with this burner. I guess the burner's broken in a good way. So I don't want that luminous flame to be used for any kind of lab work. And we're going to look at why here in a second. I'm going to take a pair of crucible tongs. Now I'm going to take a pair of forceps. And I am going to hold the bottom of this dish in the luminous flame for a little bit. And we're going to start to see something happen. Well, maybe not. I'm struggling to maintain a luminous flame here. So if we could maintain a luminous flame, what we tend to see is soot accumulation on the bottom of the evaporating dish. And soot is bad because soot is carbon. And carbon is a non-metal. Metals are good conductors of heat and electricity. Non-metals are great insulators. So having soot on the bottom of your dish means you're insulating the dish from the heat of your lab flame. And that's bad. The other thing is if we take a piece of wire and hold it up here at the tip of the flame, eventually it will turn red hot, but it's going to take quite a while. We're getting there. We're getting there. Slowly. But if we take another piece of wire and we put it right into that inner blue cone, which is a little hard to see on video, it's a little hard to see from the back of the room. If we hold it in that inner blue cone, it's going to get much hotter much more quickly because that inner blue flame is the hottest part of the fire. Still waiting. Oh, there we go. We're getting some flashes there. Trying to keep it in the flame. So yeah, we're getting some flashes of red hot. But that inner blue flame is the hottest part of the flame, and that's what we want to use for lab work. And we'll go ahead and stop there.